I want to show interesting bespoke workflow, how to gather mailing addresses from companies where you don't find those addresses with the major data providers. Sometimes there's a little bit or part of an address or no address in the CRM, but we want to make sure we have this for most of the companies and we have the most current one. So stepping back a little bit, somebody on a webinar said something really interesting. Hey, are there like Twitch streams out there of somebody building clay workflows? Because when somebody posts something on LinkedIn, it's always just the easy win, but not the blood, sweat, and tears how to get there. I want to be really clear. There are a lot of use cases where you can go into Clay, click, 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 and you get great output, especially for list enrichment. I would say that for the most part, that is pretty straightforward. Where it gets more tricky is when you build more, when you look for more bespoke data, when you look for data that, for example, is not readily accessible from one of the major data providers. And this is a good example of that. And while I won't like do a 2-hour Twitch stream on that, I want to peel back the curtain, or whatever the idiom goes. I want to just show a little bit how I build it. Um, so it takes basically an import from HubSpot that may or may not have good address data. It's not quite clear what the quality of this address data is, because even if it has an address, it may not be the mailing address. It may be an address of one of the branches versus the main branch. And this is a set where it's just a first 10 that I have in my sample. Actually, here we have quite good addresses in the CRM, but most of the part is more like what you see here, where there's part of the address or where there's basically a wrong address. So here's how this works. Let's ignore the scoring part that scores if the CRM entry how good it is basically in terms of how many data fields are filled out. But what I want to really get at is kind of the logic how to approach something like that. And there are so many ways to slice and dice this. So this is not the way to find an address. I am absolutely sure there are better ways to find an address, but there's always a better way. And this is one way to do it. So the first thing I did, it's here more at the end of this workflow, is actually look up the address myself. That should always be the first step when you do something with AI, to just know what's really true, which is the true looked up address. So just skipping to the end, this is what I started with, but I needed to compare it at the end, so I moved it there. So the first step here is really use a Claygent, which is an AI web scraper that you can prompt, like you would prompt ChatGPT, to do things. It does not, I can't say, hey, find the right address. That doesn't work. That will find something, but you need to be a little bit more prescriptive. The way I would put it is you need to give context, you need to set guardrails, and you need to experiment. And this is where that blood, sweat, and tears comes in, where there's a lot of tries to see what happens when I say, hey, go to this website and find the mailing address of the main branch. There's an infinite number of things that can come back. It sometimes said no address to be found. It gave, in one case, for some reason, I had an address of McDonald's. Okay. And there's like a lot of things there where you then realize, oh, this is what it's doing. It's looking at that address or it's doing this. And then you add to your prompt, you take something away, you make something more clear. What usually happens to me is that I prompt it and then I forget to say, do not comment on your work, do not explain your work. The prompt must have exactly this format, or the output must have exactly this format. And because of the different use cases, there are some things that you can use in every prompt, but there are things where you, for example, where you need to make really clear, no, don't use the example address I provided. This is only an example of how addresses are structured. Then maybe that makes the prompt too complicated, and maybe it just works to say, use your knowledge of how mailing addresses in the US are structured. And these are those little things where you can get to with experimentation. And I would say the more you do this, the better you get at the first shot. But use cases will always be different, so there will be always something that needs to be experimented with and discovered. Workflow. First, in terms of cost, this is in the end has run for 5,500 or almost 5,500 companies. So cost is a factor in the sense of, yeah, you can always start with GPT-4, independent of the fact that GPT 3.5 is sometimes better at these things, and also much, much, much cheaper. The philosophy from my side is always start with the cheapest model, push it to the limit, and then, which is beautiful in Clay, do a conditional run on where the cheaper model didn't find a good result, and then only there run the more expensive model. Little peek behind the curtain. This is one approach. Peek behind the curtain. That was the idiom. So that is one way to do this. The Claygent, again, an AI web scraper. I would explain that to somebody who doesn't know what this is. It's like, how would you as a person direct another capable person that has no idea what they are supposed to do to get to a result? You need to give them context, you need to point them somewhere, you need maybe to give examples, and you need to tell them how should the output look like? And then you need to let them do a little bit of their own thing. This is how this works. So in Clay, this is all done and finished, but I go here to edit column. And I don't want to like completely pick apart all of the prompts, but just some examples. Your job is to find the best address of the company, da 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 da. And then give examples of how a address is structured, and then only the address should be returned. What was really helpful was to say the address may be on a subpage, like contact us, about us, or similar. Go at least one level deep on the website. And this looks, I think, a little bit weird. Even your output in this is actually great when you have a typo in your prompt. Usually the model is smart enough to work around the typo. And I'm sometimes not even correcting typos when something works well. I would say it's a tiny bit fragile. And if it worked with a typo, I'm not going to correct the typo. So output in the following format. And then I just say the address you find. That is super powerful because it doesn't um, like prescribe a format per se. It just says, I don't want anything else than the address. I don't want, here's the address I found. I don't want, based on the website I visited, here are two possible addresses that you like, whatever. That's not something I want. And yeah, it goes on and on and on. And just to be fair, this is what you don't see in a 10-minute LinkedIn post or video. This takes a while to get there. And also, it's different from industry to industry. For this set of companies, it worked like that because most of the websites, I would say, are in one bucket of how these websites look like. That will be different for larger companies or for medium-sized companies or whatever. And so it will not work for programmatically for all addresses out there in the world. And the larger the companies get, why would you run something custom? You get the address probably from LinkedIn or like in their Impressum or whatever. So what I find is a beautiful unlock in Clay, and I posted about it earlier too, is how me as somebody who doesn't write code can run conditional formulas and like not only do this if, but like also much more nested conditional formulas. This isn't easy. One, let me just show this here. The way it works in Clay is that there's this conditional formula field. You can say use AI and then very simple, run only if a certain result is NA or empty. And what I really like is that you give this preview if any given column will run or not. So you can test if your conditional formula works the way that you want. Then you say output is correct. And this leads to this formula that will only run if this column doesn't lead to a result. What happens here? It's a slightly amended prompt, but the biggest change is that the first prompt uses GPT 3.5 as a model, whereas this prompt uses GPT-4. It is more powerful. Again, I could have chosen better examples. Sometimes it does find examples where 3.5 didn't. In this case, it's not the case, but whatever, we have a third step in the waterfall. And what happens here is because of like optimizing for cost per row, it's not just using the Clay internal Google search and the Clay internal AI model, which is currently OpenAI, but it actually leverages a custom search API, um, Clay's scraping, and then I use the cheapest Anthropic model, Haiku, to extract addresses from a data scrape. But I get ahead of myself. So here's what happens. Um, I get some results, but not all results, and I want to get more results. So this is um, a row, not a row, a column that is basically the search term I'm using for the custom search API. So I want to search on this website open corporates, which I think is kind of the crunch base of this kind of companies. It looked based on my own human research that this is the best source for addresses for this kind of companies. So what I do is I direct it to search for the company name, which I got from HubSpot, only on that website. This column that's running 200 basically means it ran successfully. And what I want from that is to find basically the URL on open corporates. Then I use Clay's scraping integration to scrape that um, that company page, and then I run a Haiku model which looks at that data scrape. So let's just look into one that we have here. In the body text, you have like stuff, and there is also an address in there. If the scrape looks differently, if for example it maps out addresses into a certain property, no problem, because what I actually did was to feed the whole scrape into the Anthropic model, meaning I'm sharing this prompt here. Your job is to find the address of a company. The data is found in the scrape here. If there are multiple addresses, find the mailing address. If there are no addresses, say no address found. And this is super powerful. There's a system prompt that I don't want it to explain. Oh yeah, hey, look, amazing, I found an address, pat me on the back. This is not what I want. A little like powerful trick is when you want deterministic results, meaning I don't want it to get creative with addresses. I want only output that is actually there. And that is the creativity. Like in LLM speak, that's the temperature, which is kind of an exponent somewhere in all of these trillions of things they are doing in the back, which leads to the model choosing not always the most likely next word or token, but maybe the second most likely or the third most likely. Of course, this is highly simplified, but what it means in the end, when creativity is low, it chooses what's the most likely next token. And that is basically what it finds. It doesn't come up with another address, another number, whatever. Conditional formula that it shouldn't run when it doesn't find certain um, when it doesn't find certain other fields, but that's not so much the center here. And then the address is found within the scrape. And again, let me walk back how we got here. I use the Claygent, which is an LLM-directed web scraper to find addresses that are on the company website. Sometimes good result, sometimes not. I want another way to get to an address if the first way didn't get there, which is do a search for the company name on opencorporates.com, find the URL of that company, um, scrape that URL, and then I direct a very cheap AI model to that scrape and have it find the address within there. Which it's important that it's a cheap model, because when you point it to the whole scrape of a website, that's quite a lot of input tokens. So for one of these Anthropic models, like I have calculated it way back in this workflow, but it's basically maybe a tenth of fraction of a cent. So basically free. 1 million input tokens is 25 cents. And one of these scrapes is, I think, 10 or 12,000 input tokens, which is why I say it's basically free. Oh, and pro tip, absolutely have your own API keys for all kinds of models out there. It makes a huge difference of the creativity you can deploy within inside Clay. And the next thing is, that's all nice and well, but that would really not be a great client delivery to deliver them one field with an address. So the next thing that has to happen is to use another cheap model to structure the address. What that does is it knows this is an address, and what I want is that it understands, in the sense of how LLMs understand things, it understands what's the street, what's the zip, what's the city, what's the secondary street, and so on, and output it always in the same format. This took so much longer than I'm willing to admit. So it was super easy. I just wrote it. No, not at all. This was, for me, difficult to write. But what I enjoy is when I have a run across 5,000 rows and it produces 5,000 dependably good results. That's pretty amazing. And it just takes a lot of tries to get there. This is like the point that I want to really get across. So yeah, let me just show it here. The model is Haiku, cheapest model, Haiku, Sonnet, Opus. Opus, super expensive, not necessary for this. And then I direct it to one of the two fields, either the address from the AI scraper or the address from the data scrape, and then where the AI found the address in there. And then I want the output only in a specific format. It should understand how addresses are structured. I give very, very, very detailed explanations how this should look. JSON is one other option, brings a few other challenges with it. So I'm just gonna just made the decision to use this. I only want two-letter state codes, and I also want title case for cities and streets, because it may look very weird, and it's just so much more human and neat when street and state and everything is in regular title case. A little bit of system prompt, so I don't get all the, hey, look at what I found for you. Conditional formula is, of course, usually part of what you do here, because I don't want it to run when there is no good data or whatever, things like that. And then I get this output, and the final step is to take this address output, which again puts together web AI agent and web scraping. The best address is being put here in a structured format, and then, and this is what Clay does very powerfully, you say look between the da 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 and extract what comes after street and before the bracket. Sometimes the model had 123 Main Street when it didn't find an address. I couldn't get it to not output this, so I had to use the formula to just ignore if the model gave this as an output. If a company is on 123 Main Street, they won't be mailed, but that is a price we have to pay in this case. And yeah, basically beautiful. It shows here the output. This looks good. And then I map out street, secondary street, city, state, zip code. I put together here. This is very simple, just the output fields strung together. This is the full AI address. This is the true looked up address. And again, this is not the address from the CRM. This is the address that I found myself. I My kryptonite is getting to 100%, which is just impossible with data like this. And so for me, it's very hard when I have a maybe or no match. But basically, I got such a high hit rate on this way of finding addresses that at one point I just got to say, you know what, this is as good as it gets, ship it. And then the fields that are very neat here are basically pushed back into the CRM. What happens client side, they have data in the CRM, we run our workflow, and they have address data for semi-obscure companies in their CRM that they wouldn't get anywhere else. I have absolutely no idea if this is interesting to anybody at all. I don't even know where I'm putting it. But anyways, if anybody made it to the end of this video, here's a cookie. And hit me up if you have questions or whatever the kids say at the end of a video.